Hello everyone, in this video we're going to be discussing section 14.6, apply sum and difference formulas, which begins on page 949. We're going to jump a couple of examples in, but first I wanted to pull up some slides with the sum and difference formulas. So we're going to continue to use these 6 formulas forwards and backwards, just depending on what information they provide and what the questions are actually asking. So in order to actually solve these problems, I should have some of these values memorized. Typically, we start out with memorizing 30, 45, and 60 degrees with just the sine, cosine, and tangent. If I have those values memorized, specifically just the sine and cosine, because you should be able to find tangent by taking that sine divided by the cosine, and we should be able to construct the entire rest of that table just through multiplication or division or taking reciprocals. Alright, some additional values that they have on there are the 0 and 360 degrees. I'll go ahead and write a 360 degrees on there. As well as all your quadrantal angles. What that means are the angles that fall on your axes, so 0, 90, 180, 270, and 360. As well as, every single other angle that has a reference angle of 30, 45, and 60 degrees. Alright, so this table is absolutely wonderful while you're doing your homework. I would definitely recommend pulling this chart back up just so that you can reference back to it. Alright, so example 3, they want us to find the cosine of x plus pi. So the first thing I need to do is find the sum formula for cosine. Alright, and by identifying this as your angle A, this as your angle B, we are then filling in the 4 places correctly with the correct sign in the middle here. Alright, and then I go to that chart and I evaluate. Alright, if I go to the chart, I can find that the cosine of pi is -1 and that the sine of pi is 0. Another way that I can do this is if I realize, well, pi is over here at 180 degrees, and that point on my unit circle, here is -1, 0. And if you remember, cosine was represented by your x value, and the sine of that pi, or 180 degrees, was represented by the y-coordinate. So it makes sense that they replaced cosine, or that value for cosine of pi is -1, and then the sine of pi is 0. Alright, so in the next step here, we go ahead and multiply those out and then combine our like terms. This second term disappears since it becomes 0, and then our final answer there is just negative cosine of x. So here in example 4, we're going to do a similar thing here with the sum of a sine, and in addition we're going to do the difference of a sine here. So we need to keep in mind our domain restrictions are between 0 and 2 pi, so that is a full circle, so we'll have to double check back as we solve this problem to see if that domain restriction holds any restrictions further on in the problem. Alright, so I use my sum and difference formulas here and replace. This is the sum formula for sine of pi over sum of x plus pi over 3, and then this is the difference formula for sine of x minus pi over 3. Alright, if you want to use parentheses, that is fine. If not, it's okay because we are using addition. If this was a subtraction symbol, you would definitely need to use parentheses because then you would have to distribute that sign. But for now, we are in the clear. Alright, so when we go ahead and write out the next line, replacing sine of pi over 3 with radical 3 over 2, and then the cosine of pi over 3 with 1/2 using our charts. then we can go ahead and combine our like terms. And we see that this positive radical 3 over 2 times cosine of x minus radical 3 over 2 times the cosine of x cancel out, and I am left with this 1/2 sine x plus 1/2 sine x, which gives me that 1 sine x, which you don't even have to write that coefficient of 1 in, it's just 1 sine x. Alright, and since that equals 1, you can type into your calculator the sine inverse of 1, which equals pi over 2. If your calculator is in degrees, it would come out to 90. And anytime you have a sine or a cosine that is equal to a 1 or a 0, you can always check your quadrantal angles here. So this one is 1, 0, this is 0, 1, this is -1, 0, and this is 0, -1, and you are checking the second coordinate, the y coordinate. So here at 0 degrees, sine of 0 is 0, and here the sine of 90 degrees, or pi over 2, is 1. Here it's 0, here it's -1, so there is only one solution at pi over 2. So moving forward to example 5, daylight hours. A number h of hours of daylight for Texas, or for Dallas, Texas, and Anchorage, Alaska, can be approximated by the equations below, where t is the time in days and t equals 0 represents January 1st. So if I were to talk about t equals 15, that would be January 15th. Alright, so on which days of the year will the two cities have the same amount of daylight? Alright, so we want the amount of hours to be equal. So we're going to go ahead and we're going to take these two equations, h1 and h2, and we're going to set them equal. Alright, so here is step 1 written out, me setting both of those equations equal. Our whole goal here is to solve for time t, so we're solving for a day, and we'll get a certain number, and then we'll correlate that with a certain date in the year. So right off the bat, I'm noticing that I've got a plus 12.1 in both of the equations, so I'm thinking we can go ahead and subtract 12.1. And then, in addition, I have a 2 and a -6, so I'm going to divide each side by a positive 2, which results in this step right here in that second line. Alright, so then I'm going to use a difference formula since I've got two technical angle measurements here. I've got pi t over 182 minus 1.35. So using the difference of signs, the equation for that, I result in the left side of this equation here. And then in the next step, I actually compute what the cosine of 1.35 is and the sine of 1.35, and I get some actual numerical values there. So then in our next step, I would go ahead and combine my like terms. So I'm going to go ahead and add this entire cosine value over to the other side to combine with this cosine, since the angle measurements are the exact same. If the angles weren't the exact same, I wouldn't be able to do this. Alright, so then I get that -3 plus that 0.976 cosine, and that is what results in the -2.024 cosine of pi t over 182. Alright, and of course I moved this number out here in front as a coefficient. Alright, and so then I have a couple of trains of thoughts. I would like to go ahead and, move this number to one side or the other, and then the sines and cosines onto one side. Alright, so what they do is they divide each side by cosine so that they get sine divided by that cosine of pi t over 182, and they do the exact same. Alright, pi t over 182, and the reason why they do that is because sine over cosine equals tangent. Alright, so then, moving from the left to the right, they decide to divide each side by that 0.219, 0.219, which is how they get negative 9.242. Alright, so now I've got the tangent of some angle equals a value. So in order to actually find the measure of this angle, I take the tangent inverse of both sides. So when I do that, I get pi t over 182 equals the inverse tangent of negative 9.242. And then they go ahead and add on that plus n pi, or plus that pi n, however you want to write it, because tangent is cyclical and it repeats after a period of pi. So there might be multiple values here that end up producing a true statement. So I need to add n pi in order to accommodate for that. If this were sine or cosine, I would add on 2 pi, since it repeats after a period of 2 pi. Alright, so then evaluating that inverse tangent, I get negative 1.463. So then I need to solve for t by multiplying each side by 182 and dividing by pi, or multiplying by the reciprocal 182 over pi. Alright, onto each side. So when I do that, I need to actually distribute it to every single term. Alright, and when I do that, I get approximately negative 84.76 plus 182n, since the pi's are going to cancel out with that right term. Alright, and it is approximately. So, step 2 here, I need to find the days within 1 year, so that's 365 days, in which both Dallas and Anchorage will have the same amount of daylight. Alright, so I substitute in 1. So what if n equals 1? And then I'm going to substitute what if n equals 2 or n equals 3. Alright, so n equals 1 comes out to approximately 97. So counting your days there, that would end up on April 8th. And then if I plug in 2, I get 279, and with an obnoxious amount of counting, I end up on October 7th. Alright, and if I were to plug in 3 there, it wouldn't come out to another value that would end up within 365. So I can stop there, and these are the 2 solutions. Alright, so guided practice 3 here, or sorry, the next guided practice 6. Find the sine of x plus 2 pi. So you're going to want to use those sum and difference formulas in order to evaluate. So obviously here it is a sum. Feel free to pause the video and then check out your solutions and verify. Alright, if you guys have any questions, always feel free to send me an email and check me out on a Google Hangout. If you guys need some extra one-on-one, please don't be afraid to reach out. I look forward to hearing from you. Good luck.